Okay, so here we've got a lift accelerating upwards. Okay, so you can see my acceleration going upwards there. And the tension in the cable is 9,000 newtons. And then notice here I've got my weight, okay, which is a combination of the child's mass and the mass of the lift, okay, of course times in my gravity there. That gives me the weight. So you've got to put the child and the lift together to give you a total of 750 G. Okay, and it says then calculate the value of A. So basically we want to find acceleration, so we can say using Newton's second law, okay, resultant force. Now, because we're accelerating upwards, right, the lift is going upwards, the 9,000 newtons is going to be greater than the weight, yeah, it's got to be, isn't it? The tension in the cable has got to be greater than the combined weight here in order for it to move upwards. So there's got to be a greater force in that cable, greater tension there. So 9,000, if we take away then what's dragging it back, what's pulling it down, which is this here, the child and the lift, which is 750 G. That will then equal, right, mass times acceleration. So the mass then will be 750, yeah, times then the acceleration. Okay, so that's my Newton's second law there, alright? And quite simply, I got that by resolving in the vertical direction and going in the direction of acceleration, okay? So the lift is accelerating upwards, and you just need to appreciate that if it is accelerating upwards, the force here of 9,000 newtons has got to be greater than the weight of the lift for it to overcome the weight, yeah? If it's going to overcome the weight and actually pull it up, that's got to be greater than this, okay? So we use Newton's second law then, resultant force, which will be the upward force, take away then the resistance, the weight there, would equal then mass times acceleration. So the mass, the combined mass of the lift and the child is 750 kilograms times the acceleration. In this case, I'll just chucking in numbers. Gravity is 9.8 times 750 times A. If I work that out, I need to have a subtract there, don't I? So 9,000, take away 750 times 9.8, and I get 1650 equals 750 times A. And then to get A then, I divide by that 750. And I get 2.2 meters per second squared. Okay, so that's my acceleration. Part B then, it says modelling the child as a particle, find the reaction between the child and the floor of the lift. Now what we do next is we sort of home in on the forces, the internal forces that act on this child. Okay, so again I'm going to draw a new diagram with the child is sort of the focus. So I'll just model the child as a particle. Okay, now that child's got a weight 30 G, 30 kilograms, so 30 times G. And then of course there's going to be an upward reaction. Okay, reaction from the floor pushing that child up. But the lift isn't stationary, the lift is moving, okay, at an acceleration of 2.2. That's what we just saw in the last question. Okay, that's what we worked out in part A. So it's not as if the reaction can equal 30 G, because it isn't, right? It's not going to equal it, right? The fact is, this lift is moving, it's accelerating upwards, so you use Newton's second law again to work out what R is. So because it's moving upwards, this R is going to be greater than the weight. So resolve in the direction of acceleration, R take away 30 G equals the mass, which is 30, times then the acceleration, 2.2. So R will be, R take away 30 times 9.8 equals 30 times 2.2, which is 66. So R minus 294 equals 66. So R will equal to 66 plus 294, which is equal to 360 newtons.